Hey everybody, your Friendly Math Tutor here with video number 4 of our SAT one-sheet breakdown series. So before we jump in, make sure you realize that down below we have the PDF files of both the actual one-sheet and all of the examples that we'll go through in today's video. All right? Make sure we subscribe to our channel. Check out our Facebook, TikTok, and Instagram for more videos on SAT. Even got some AB, BC calculus stuff out there, and we'll keep adding more. All right, so let's dive into the one sheet today. All right, so today's focus is part 3. So we're on the back of the one sheet now. Important concepts. And the important concepts we're going to focus on in this video are polynomials and complex numbers. So we look at important concepts, and let's start with polynomials. And with polynomials, we've got a section on talking about factors and then another section just talking about general factoring methods. So let's jump into our factors. And we've got 2 examples here. And our first example has to do with the idea of they're going to give you something as a factor, and we have to know the relationship between a factor, a zero, and an x-intercept. So for this one, if x plus 1 is a factor, we have to know right away that that means -1 is a 0. And what a 0 means is it's an x-intercept, and it means when you substitute it into the function, so that p of -1 should equal 0. That's the key to this problem. That's how we're going to find k. So if x plus 1 is a factor, we don't have to factor this. We could guess and check and get the answer, but I feel like that's kind of difficult. The easiest way to do it is just to understand this relationship between factors and zeros. So when we substitute -1, we should get 0 as an answer. So 0 equals 4 times, -1 cubed minus k times -1 plus k. That means 0 equals -1 cubed is -1 times 4 is -4. Minus k times -1 is plus k, plus another k. So now we've got, I'll add the 4 to the other side. So 4 equals k plus k is 2k. And now we can see if I divide each side by 2, then I should get k equals 2. So that's the value of k. Let's take a look at another problem that is similar to this concept. Here's a graphing problem. So again, zeros, x-intercepts, and factors all have this relationship. And each of these is broken down into factors, and we want to figure out what the zeros are. But the zeros are just the x-intercepts. So the graph has x-intercepts here, here, and here. So x-intercepts at -4, 0, and 3, which means we're going to work backwards here. The factor that goes with -4 would be x plus 4. The factor that goes with 0 would be x, or possibly a higher power of x. We'll discuss that in a second. The factor that goes with 3 is with the 0, 3 is x minus 3. So first of all, we need to have an x plus 4 and an x minus 3 in our problem. So that gets rid of a and c. So it's between b and d. Now, 0 could go with x, x squared, x cubed, x to the 4th. So clearly looking at our answers, it's either x or x squared. To understand that, we have to further understand the graph of a polynomial. If you look at the behavior near 0, you see it's a parabolic behavior. It's kind of hitting the x-axis and bouncing off. That's going to happen whenever you have an even multiplicity, and the multiplicity is just the power that we have on the factor itself. So notice that these other two have multiplicity 1, which is why the graph just goes through like a linear function in both cases. But at 0, it bounces off. So that means x is not good enough. It has to be x squared to give us that kind of bouncing action, or think x squared like a parabola. So the answer has to be D. All right, so let's keep it moving and look at the other types of polynomial problems. So now we look at general factoring methods. And just in general, if you have two terms, you're going to look for a GCF or a difference of two squares. So let's take a look at number one. So if we just try to factor this, GCF first. So 2 times 4x squared minus 1. And then look for a difference of two squares. Well, 4x squared minus 1 is a difference of two squares. So that becomes 2x plus 1 and 2x minus 1. So therefore, the function is divisible by 2x plus 1 because 2x plus 1 is a factor. So that means 1 has to be in our answer. That doesn't really help because they all have 1, which really means if you were actually doing this problem on a test, I wouldn't have even checked 1, considering it's in every answer. I just want to go over it right now with you to go over the concepts. But again, no need to do that. Okay. So now when we check number 2, this one I'm going to factor over here. This one is it's 3 terms, so we're going to do the AC method. So we're going to do 2 times 4 is 8. Factors of 8 to add up to -9 is -8 and -1. So I'm going to rewrite it as 2x squared minus 8x minus 1x plus 4. Take out the 2x and I get x minus 4. Take out the -1 and I get x minus 4 again. So then I get 2x minus 1 times x minus 4, and that is not divisible by 2x plus 1, so 2 is not in our answer. So I'm going to get rid of b and d. So now we do have to look at number 3. Number 3 is 4 terms. When there's 4 terms, you're going to look for a GCF, which this doesn't have one, but it is factor by grouping, which I actually did in the AC method. So if I factor by grouping, I'm going to factor out 2x squared from the first one, which leaves me with a 2x plus 1. And then I'm going to factor out a -3 and also have a 2x plus 1, so I can see that I will have a 2x plus 1. But just to finish this, I have 2x squared minus 3 times 2x plus 1. So it is divisible by 2x plus 1, so it works for 3. So the answer is C. So just to recap, this gives you a little cheat sheet as to what you should be looking for when you're factoring things. I would say in this one, don't check number 1 because it's part of every answer. But you would only have to check 2 and 3. That would just limit the amount of work. I just went over it again just so I could go over all the methods. That's why I chose this problem. All right. Let's take a look at our last problem with polynomials. And this one is solving an equation, which we're going to use factoring eventually. So we're going to start by distributing. So we're going to get x to the 6th minus 9x squared equals 8x to the 4th. Then I'm going to, when I'm solving a polynomial equation, I want it to equal 0. So I'm going to bring the 8x to the 4th over and put it in the middle here, like that. Now what I'm going to do is any problem, notice I always wrote look for GCF. That should be the first thing that you do. So we're going to take out an x squared, and then we're going to be left with x to the 4th minus 8x squared minus 9, equals 0. Now this can be factored. Well, if you have 3 terms, try the AC method. This one, we don't have to do the AC method. We could, since the a is just 1, we could break it down into x squared and x squared. Look for 2 numbers that multiply to -9 and add to -8. That is -9 and +1. So now we could set each factor equal to 0. This factor, when you set it equal to 0, is going to give you 0, but it says x is greater than 0, so we don't have to worry about that. When we set x squared minus 9 equal to 0, we're going to get x squared equals 9. Take the square root, we get plus or minus 3. But again, we only want the one that's bigger than 0, so our answer is 3. If you check x squared plus 1, you will get an imaginary number, so you don't have to worry about that. So the only answer we have for this problem is 3. All right, so that's how, remember, when we're solving a polynomial equation, we need everything to equal 0, and then we factor. Here's, again, just our quick rules on what to look for whenever you're factoring. All right, let's head back to our one sheet. And now we're going to dive into complex numbers. So the first thing we're going to look at is powers of I. So you have to know, obviously I squared, or sorry, I to the first is I, but the most important thing is that we know is that I squared is equal to -1, and then I cubed is equal to -I, and I to the fourth is equal to +1, and then it just repeats from there over and over and over again. Well, in this problem, we are going to have 1 over I, because I is just I. Now 1 over I squared. The thing about 1 over I squared is that's 1 over -1, so that's -1. And 1 over I to the fourth is 1 over 1, so that's +1. So the -1 and +1 goes away, so the answer is 1 over I. But I don't see that answer there. So also what we have to do with complex numbers is we have to know how to multiply top and bottom to clear the I. So if it's just I would just multiply top and bottom by I. That way I'm going to get I over I squared. But I squared, again, is -1. So I have I over -1, which is really just -I. So the final answer is A, which is -I. All right, so this is kind of like rationalizing when you have a radical on the bottom. It's the same concept. We'll see when we have a binomial on the bottom how that'll look a little different. All right, and now let's go back. All right, so let's move on to our next complex numbers example with powers. So we did that one. Now let's take a look at this example. I'm doing 3 and 4 first, so I put these out of order. We'll do example 1 and 2 next. No big deal. All right, so we get to our next powers of I problem. So it says I to the m equals -I. We're trying to figure out which one would equal -I, or in this case, which one cannot be m. So this one's actually pretty simple. So notice that anytime you raise I to an even power, you're either going to get 1 or -1. And this pattern repeats. So it'll be like I to the 6th, I to the 8th, I to the 10th. They're all going to give you -1 and 1. So if we have an even number here, then there's no way that we're going to get an I in our answer, a -I in our answer. So the answer has to be 18 because that's even. Furthermore, in a problem like this, if you did have to figure out, for instance, what I to the 15th would be, you could do 15 divided by 4, the number of terms in our pattern, and that would give you 3 with a remainder of 3. And the remainder of 3 tells you that it's -I. So remainder of 1 is I, remainder of 2 is -I, remainder of 2 is -1, remainder of 3 is -I, remainder of 0 would be 1. You wouldn't have a remainder of 4 when dividing by 4. All right, but we don't have to check these because they're all odd, so the one that cannot be -I is the even number. All right. So now let's jump back. So I did these out of order. Now we're going to go to dividing complex numbers. This one is going to be example 1 and 2. All right. So let's take a look at this. So when we simplify something in this form, we are going to multiply by the conjugate of the denominator. So that means I'm going to multiply top and bottom by 3i plus 2. So in the numerator, I can do FOIL. So 2i times 3i is 6i squared. 2i times 2 is plus 4i. Then 1 times 3i is plus 3i. And then 1 times 2 is plus 2. In the denominator, I don't have to do all of FOIL. I only have to do the first and the last. So I'm going to get 9i squared. Then the middle terms are always going to drop out, which is the reason that we're multiplying by the conjugate. So don't worry about those. Just do the -2 times 2. So that's minus 4. Now in the numerator, we're going to get some like terms. This is 7i. And what happens is 6i squared. I squared equals -1. So 6i squared is really 6 times -1, which is -6. And -6 plus 2 is -4. So that's our numerator. Now again, 9i squared is really -9. So -9 minus 4 is -13. And then if we split this up, this is -4 over -13 is 4 over 13. And then that's minus 7 over 13i. This is if we just get it in the a plus bi form. And the value of b is just the coefficient of I, in this case is negative 7 over 13, which is letter C. All right, let's take a look at our last problem. So again, I did examples 3 and 4 first, and now I'm doing examples 1 and 2. And in this one, we are trying to add complex numbers. Well, anytime we add any fractions, we have to get a common denominator. So I'm going to multiply this one by 1 plus I to get a common denominator over 1 plus I. And in this one, I'm going to multiply by 1 minus I over 1 minus I. And let's figure all this out. So on this one, if I do FOIL, I got 1 times 4 is 4, and then plus 1 times I is I, then I times 4 is 4I, and then I times I is I squared, over. Now on the bottom, these happen to be conjugates. So I did it because of the common denominator, but they are conjugates. So I only have to do the first and the last. 1 times 1 is 1, minus I times I is minus I squared. Now I have the other one. So the other one will be 2 times 1 is 2, minus 2I, minus I, and then minus I times minus I is plus I squared. And then on the bottom, I have the same thing. I better have the same thing because I got a common denominator. All right, so let's keep going. So we have now in the numerator, what I'm going to have is like terms. So this gives me 5i. But here I got 4 plus I squared, but I squared is negative 1. So 4 plus negative 1 is 3. Now on the bottom, I have negative I squared. Well, I squared is negative 1. Negative negative 1 is 1, and 1 plus 1 is 2. So my common denominator is 2. And then here I have 2, but I squared is negative 1. So 2 and negative 1 make 1. And then I have minus 3i. Finally, well, I guess I have 2 more steps. So now I can combine like terms. So 3 plus 1 is 4. 5i minus 3i is 2i. And that's all over 2. So if I divide everything by 2, I get 2 plus I, which is answer choice B. All right, so that brings us back to our one sheet. So in this video, we went over polynomials and complex numbers. So in polynomials, you really have to understand the relationship between factors, zeros, and x-intercepts. You have to know the various factoring methods and how to get started with a problem. Always look for a GCF first and then try the other methods. If they don't work, or even after you factor out a GCF, you're still going to look for the other methods. Then in complex numbers, you have to know the powers of I, that they repeat after you the first 4. And then anytime we are simplifying a dividing problem, we're going to multiply by the conjugate of the denominator. And anytime you have I squared in general, after you do FOIL, you should know that I squared is negative 1. It brings us back to the powers of I. All right. Okay, that is the end of video number 4. So I hope that was helpful. Check out the other videos on all the other sections of the one sheet, and make sure you subscribe to our channel. Check out our Instagram, Facebook, and TikTok, where we've got other videos on SAT and AP calculus, and we'll be putting up a lot more videos as we go along. All right?